Perusahaan sosial itu adalah satu entiti yang tidak menolak soal perniagaan. Maka dalam tafsiran kita as social enterprise, you have to be a for-profit organisation. That means you have to have a going concern. You have to be a business, because we still believe that only through businesses are you incentivized enough to create a going operation. Tetapi kita nak pastikan bahawa ia bukan hanya soal perniagaan. Ia bukan hanya soal your EBITDA and also your shareholder value. But what is it that businesses are leaving behind for the community? And what are the businesses doing for the community in order to make it more sustainable, in order to address inequality, and in order to do good? Itulah kenapa perusahaan sosial ini menjadi satu entiti yang penting untuk kita bangunkan. Dan saya melihat bahawa perusahaan sosial ini ada peranan yang penting bukan hanya dari segi inovasi bagi menyelesaikan masalah setempat, tetapi perusahaan sosial is a new model for businesses to contribute to the economy.
Very important that for policymakers to lift this or to extend this, it must be based on science and epidemiological facts.
Robotik, artificial intelligence, semua jenis teknologi yang diperlukan kita sedang kembali bagi membantu kerajaan.
Hello, everyone. Good to be here. My name is Sufyan Zamali, and I am from FSR Technologies Negara Berhad on behalf of Kumpulan Modal Perdana. So we are very honored to be presenting today for the Minggu Sains Kebangsaan 2021. Today, I will be sharing about something that I name Becoming a Nation of Hardware Tech Producers. So I was made to understand that the audience today are high school students. Most of you are from Form 1 to Form 5. So today I will try to keep my presentation as generic as possible so that all of you can follow. Okay, a general outline of what I will be talking about. So I will start by introducing who we are, and then we'll talk about hardware technology as an introduction, followed by fundamental principle of product development, and then we will talk about product specification workflow. And this is going to be followed by product development process. And then I'll have a discussion on a topic called deadly sins of product development. And finally, we will conclude with a question of why you should consider doing hardware tech startup. Okay. Okay, so as I mentioned, my name is Muhammad Sufyan bin Zamali, and I'm from FSR Technologies Negara Berhad. We are a hardware company. We are a homegrown hardware company, and that do our R&D 100% in-house. So we were established in 2011. We build a hardware called engine control unit. We design, develop, manufacture, and distribute everything ourselves. Okay. The manufacturing part, we do have some outsourcing, but the final packaging and the testing is done in-house. So we are located in Bukit Jelutong, Shah Alam. We have 15 total employees. We market our product in all over Malaysia and also in some countries in Southeast Asia, Thailand, Philippines, Singapore. So as I mentioned, we developed a product called ECU. So what is an ECU? So ECU is known as engine control unit. So for any combustion engine, the engine can be regarded as the heart of the vehicle, and the ECU is like the brain. So the engine will provide sensor data to ECU, and the ECU will determine the combustion parameters of the engine. For example, the fuel injection time, spark ignition time, the fuel injection amount, and many other things that the ECU will decide. So basically, it's the main controller of the engine. So if you think about it, it is a very multidisciplinary domain because it converts the chemical reaction information into electronic signals, in which the ECU will perform some calculation through its firmware, and then it will go back sending electrical signal to some mechanical actuators inside the engine, such as the injector, fuel injector, or the spark plug, the fuel pump, etc. So it's a really multi-domain. It's a multi-domain hardware. So our product is called TuneBoss. So TuneBoss is our brand name. It's an aftermarket ECU for motorcycles. So why do people buy our product? Because it improves engine performance, improves fuel consumption, and also we provide a lot of advanced diagnostics for the motorcycles. So we changed the game for motorcycle ECUs. We started selling this in 2014, and it was the most advanced product of its time. So innovation. So TuneBoss, our ECU, is the first ECU in the world that integrates wireless communication that enables smartphone connectivity. So it was like magic, because at that time, 2014, the smartphone adoption was just picking up in the world. So IoT, or Internet of Things, if you have heard of it, is a relatively new term in the market. So by integrating Bluetooth as a wireless communication protocol inside our ECU, the engine control itself becomes an IoT device. Okay, so you can configure the parameters using a smartphone app that we have, and also we have some cloud-based services. So we believe that we were the first one that have this integrated wireless integrated inside an ECU in the world, because maybe about a year or two after we launched, we saw in the news that some of the major ECU manufacturers, such as Bosch, they released a version that has similar capabilities. So today, wireless connectivity on ECU is quite common. But back then, in 2014, we were practically a trailblazer, we believe. So that's pretty much an introduction of what we do. Like I said, we are a hardware technology company. We actually build products, physical products, okay, not just software. So as you guys have heard probably a lot these days, the terms IR 4.0 or Internet of Things, IoT. So those terms are being used a lot today, but many people do not understand what the definition really is. Okay, so we'll look into that. So hardware tech, right? So as a definition, hardware technology, or I would like to focus it more on a consumer hardware startup. Okay, so a consumer hardware startup is a technology company that focuses on delivering products and or services to individuals or households through physical electronic devices. Okay, and usually there is an accompanying software created to enhance the experience of the product. So physical electronic devices, meaning you have an actual product that you can hold in your hands, okay? And I would say that hardware tech should contain a very unique smartness inside the device itself. It's just not just collecting data and sending to server and have all the computation and processing done in the server. That is IoT, Internet of Things. But as a consumer product, your product need to have some unique processing capabilities. So, for example, in our case, in our ECU, we process the combustion parameters on the device itself. Okay, so our firmware contains smartness that can do a lot of real-time processing. Okay, so this is what we define as hardware tech. So let's just go through some examples of familiar hardware devices or hardware tech that exist in the market. So I believe most of you can recognize what this is. Okay, this is a drone. A popular brand would be DJI. So a drone is a hardware technology because it contains an actual device that can, fly and process images and videos and things like that. Okay. So next would be something like this. This is a toy. Okay. This is a BB-8 character from Star Wars. It's a toy robot. So this is also consumer hardware because you process the actuation or the movement of the robot on the device itself. Something like this also can be considered hardware tech. This is a smart weighing scale. Okay, so it replaces the traditional analog scale that has existed for a long time. Okay, now your data from the weighing scale can be connected to a cloud service, and you can, record historical data on your phone. Something like this. This is a GoPro action camera. Okay, so it is definitely a hardware technology because there's a lot of smartness in this camera like this. Okay, it's not just taking pictures, right? You can actually do a lot of processing in it and image stabilization and so another familiar hardware, GoPro. Now, what about this? Can any of you recognize this? Okay, so this is made by Apple. This is called Apple Newton. It's a personal digital assistant. Okay, it was produced by Apple in the early 90s. So you can imagine this is the grandfather of your iPhones today. Okay, so Apple came up with this product as a personal digital assistant. It was the first product in the world that has handwriting recognition. Okay, technology. So it was ahead of its time. The product did not gain much traction, as good as Palm Pilot much later. But historically, this was what Apple produced as a handheld gadget at that time, the first one, before they launched iPhone in 2007. So let's just take a minute and compare, do a bit of a comparison between a hardware and a software startup. Okay, hardware startup, when I say startup, is a business. So a hardware technology or software technology business or startup. So examples include for hardware, as we saw just now, smartphones, drones, those are hardware companies. Software would be something like a mobile app, like game, your Candy Crush, or your any productivity apps. Online services, such as Grab or things like that. Some marketplace platform. So those are hardware-focused business or hardware startup, software startup. Sorry, so software-focused business. So what's the difference? Okay, so basically, both software and hardware startup or technology business have their own pros and cons or ups and downs. Okay, software is definitely less expensive to start. It's easier to create and distribute, because you just need a PC and you can write some codes and you are good to go. So the capital requirement for hardware is much higher than software. Software is also more scalable than hardware. Basically, you can scale indefinitely, right? The cost is the same to distribute your software product to 100 people, 1,000 people, or 100,000 people. Okay, but for hardware, the cost would definitely increase as you increase your the number of people you reach. Okay, that's why the barriers of entry for hardware is higher than software because of these factors. It costs more to start. Okay. For software, if a customer doesn't like it, you can just refund their money and there's no real loss. But for hardware, you need to actually manufacture your product, so you need to buy your raw components, your raw materials, and you have to go through a lot of processes. So it's not as easy as just discard what you develop. Okay. So the downside is, because software is much easier to start, okay, there are more competition. Okay, so anybody can start their own software or IT or software related business or software technology startup. Okay, so it's important for the businesses to build their brands quickly and capture market share. Okay. So hardware is more difficult and more expensive to start. So you would eliminate a lot of competition from the beginning. Okay. And then hardware has patents. Okay. So you can apply for patent to protect your idea. Software, you cannot do that. Anybody can do what you do. Anybody can duplicate. It's just a matter of speed to market. And then finally, hardware also has a potential for a retail business. Means it's a very traditional business model that has been around for hundreds of years. Okay, you have physical product, you go to the shop, you can sell it to people who walk into your store. Okay. Yeah, so this is pretty much a rough comparison between hardware and a software startup business. So how to start a hardware tech business? Okay, so just sharing the experience that we had doing this, okay, for 10 years. So essentially, first you have to figure out what to build, and then you have to build it and you sell it. Okay, very easy, very straightforward, but there's a lot more into it lah. But the first part is to figure out what to build. You have to specify your product. So this is product specification. How to define what your product will be. Okay. So we will go through the first. The next part will be product specification workflow. After you have specified what you want to build and what you want your product to be, you can build it. Okay, that is product development. And then finally, once you have the product, once you have it manufactured, you can sell it. Okay. So we will, in this talk, I will focus more on the first two, product development and product specification. Selling your product is a whole another topic on its own. So maybe we'll do that at some other time. So product development, right, has one fundamental principle. Okay, this is a basic truth that applies to any product development. Okay, which is surprises only get more expensive if discovered later. Okay, putting it in other words, essentially product development is an exercise to uncover as many surprises as possible as early as possible and eliminate them in the early stage in the development as possible. Okay, so this is the basic truth. Okay, because the later you discover a surprise, the costlier it will be to overcome it. Okay, so if you uncover a surprise at the design stage, right, you would only need to change your design. But if you discover a fundamental surprise much later, when you have already built your prototype or when you have already sent your project or product to be manufactured in the factory, right, you already have bought like your components, and then you suddenly realize that, oh, your components don't match or your components value is insufficient, right? There are real costs involved because you would have already spent a lot of money to purchase your raw components or raw materials. So you would want to make sure that any problems or surprises is discovered in the early stage as possible. Okay, that's the fundamental principle. So now let's go into the product specification process. Okay, so what it means by this, what is meant by this. Okay, so this is a big picture of a product specification workflow. Okay, as you can see, there are a fair number of tasks that lie between the having an idea to actually manufacture your product. So this is some of the steps involved in this illustration. It's not a universally accepted rule or anything, but it's actually it's really a general take of what normally happen during product specification. Okay, so let's first take a look at the first three boxes at the top: user stories, use cases, and requirements. So basically, product specification starts with turning mental images of our product into physical design and turning mental videos into requirements that support the ways of using our product. Okay, so what does that mean? So user stories or use case, basically it's something like a high-level activity, including the person who will perform the activity using your product. For example, you want to build a smartwatch, right? So you would have to imagine what you want your smartwatch to look like. What is it supposed to do? What features does it supposed to have? Okay, and then you turn that into a requirement. Okay, so here a note is you have to note that when you turn into a requirement, okay, you need to ensure and you need to take care of form and function. Okay, the form of your product and the function of your product, they both must coexist. Okay, what are form? What is form and what is function? Okay, form is how your product will look like. Okay, what color, shape, size. Okay. And then function, of course, like what is supposed to do. So there are products that have that place more important form than function. For example, toys, or like I mentioned just now, smartwatch, wearables. Okay, form is more important because your user will interact physically in real time when they use the product. Okay, when, for example, the toys just now, when kids play the toys, right, they actually have to touch and play. So how the product looks is very critical. Okay, you want to make it attractive. Okay, but there are products that have more places more importance in function over form. For example, our ECU, right? Our ECU, not to say that form is not important, but it's not critical because it's more of a functional product. The product sits inside the motorcycle. It's expected to perform the role it's supposed to do without the user actually looking at the product while it's being used. Okay, so a lot of automotive products are similar in nature, where function is more important than form. But generally, I would say it's a mix of both. All physical products, all physical hardware technology product is a combination between form and function. You know, they lie between these two extremes. So a lot of intelligent products with embedded electronics tend to fall into a category of, we know what functionality we want, right? How can we make this functionality as attractive as possible? So before you spend too much effort creating a smart product, you want to create the physical looks of your smart product. So you should think about the details of your product's function, and in turn, the product will function will flow from how your product will be used. Okay, so you have to have a good feel of function, and then based on that, you have to create the physical design that supports it. Okay, for example, the robots, right? You want, like, for example, robot has 2 arms, right? So you need to create a robot that is aesthetically pleasing, and has these 2 arms on the sides that functions, So it's a combination of both form and function. After you have your requirements, right, then you would need to create your system architecture of your product. So what is system architecture? Architecture is actually a way to break down your complex product into smaller, abstracted, functional building blocks. For example, you could say that you would need to create electronics architecture. You need to decide on a mechanical architecture and also a software architecture. These are some of the major architectures that involve in your overall system architecture. Okay, what's electronics architecture, for example? So let's look at electronics architecture. So it is basically your circuit design. Okay, I'm not sure how much of a circuit design theory that you guys know, but just roughly, for example, you would need like a phone, right? You need a microcontroller, your RAMs or your ROMs, and you need your power supply, which comes from the battery. And your phone, for example, has an accelerometer, okay, to determine the physical orientation of your product. And then the phone would also have a radio transceiver to receive and send signals, through 4G, 3G, whatever. So this is generally the top level requirements for your electronics architecture. Okay, and then also need some mechanical architecture. So mechanical architecture includes enclosures, motors, gears, linkages. Okay, for example, what you see here is a picture of a paper feed mechanism from an inkjet printer. Okay, so the mechanical architecture, the mechanical requirements is for this machine to grab a single sheet of paper from a stack and then move it through the printer so that you can go through. You can print on the paper, but you need really high accuracy. Otherwise, if it's not accurate, some small misalignment can result in very bad printing output, right? So, and then you need to be very precise and repeatable. You don't want to damage the paper, right? So you can see here the assembly is really non-trivial. Okay, it has a motor driving various gears. It has rubber wheels, rollers, springs, and other bits. Okay, so when you design a product, you need to consider this architecture also, how your mechanical architecture interacts with your other parts, your electronics and your software. So even if you don't have complex mechanisms like this, you would want mechanical enclosures are also part of mechanical architecture. Okay, so for example, in our case, it would be just the casing enclosure and also the connectors, right? So you would need to make sure that the enclosure size is determined well so that the placement of the product fits into its bigger placement, right? You want to make sure that you have enough, your enclosure is big enough to accommodate the printed circuit board you would need to build later. Okay, and you need to have the correct connectors, okay, and waterproofing, things like that. So another part of architecture would be the software architecture. Okay, so as I mentioned just now, you would have firmware. Firmware is the software that goes into the MCU that perform a specific task, okay? A well-defined task. So in the firmware, do you need an operating system, right? So for example, things like drones or phones, right, or smartwatch, you would definitely need an OS. Okay, otherwise, much simpler products, you can just live with some interrupt handlers. Okay, you don't need an operating system, which has a cost. Okay. Apart from firmware, you would also need to determine your application software. Okay, so your application software you want to make it on which platform? Do you want to support both iOS and Android, or Android only and web or desktop? So these are the consideration you need to make before you decide on your application software, because there are challenges on doing or creating the software on each platform. Okay, do you want to make it native? Means iOS stands on its own using its native platform, Android native, or do you want to consider cross-platform? Means you create one base architecture, and the cross-platform technology can compile it to iOS and Android. For example, things like Flutter by Google or React. You can just create one code base and it can be ported into iOS or Android. So there's pros and cons of these things. So you have to consider. Depends on your budget, depends on your resources. So those are some architectures involved in your product development, product specification. So once you have this architecture, you develop your product, then you would need to create your prototype. Okay, so in this case, electronics architecture, for electronics, you would have your breadboard. Breadboard is where you can use through-hole components, and you can create your circuits on the breadboard to test out your logic. Okay, and then mechanical architecture, you can use 3D printers, 3D printed parts, for example, before you actually put a purchase order on injection molded parts. And then software architecture, software you can just develop on the platform that you choose, right? And then you try to combine all these into something that is called a prototype. Okay, it has to work like and look like what the end product would be. Okay, industrial design is something that is considered the user interface or user experience of your product. Okay, or it will define the product looks. Okay, the software, the packaging, the styling of the product. Okay, that's what industrial design means. And you can actually file for trademark on your industrial design so that people cannot copy your shape. It becomes your own property, intellectual property. Okay, so yeah, so basically, once you manage to integrate your electronics and your mechanicals into a full functioning prototype, then that is a huge development, a huge milestone in your development. So because you would actually start to feel that there's a real product emerging from your effort. Okay, so sometimes at this point you would discover issues, like for example, you found that, oh, this part does not fit together well, it's too tight or too loose. Sometimes you discover, oh, the cables are too short, connectors cannot be mated because of other components, or basically the size of the enclosure is not enough because you would need a bigger PCB or printed circuit board because you want to process more logic than the previous plan could handle. So you would need to add more components. You need to add more larger dimensions. So larger printed circuit board, a larger PCB will require a larger enclosure. Okay, so at this point you would reiterate your prototype and fine tune your design until you converge into a design that is worthy of being sent to high volume manufacturing. Okay, so you will never get everything right the first time. So you would need to do a lot of iteration to make continuous improvement. So for example, this is the picture here shows a prototype of a smartphone, a smartwatch. See, this looks like a Frankenstein, right? It has a display, wires here and there, and a lot of sensors integrate, just prototype sensors, and you go from here, from this prototype to the finished product here. This is a Garmin smartwatch, right? So it looks really nice, really cool. So this is a result of integration of electronics, mechanical, the looks, the buttons, the physical aspect, industrial design, as well as the software that goes into it. So this is how an example of how the converging of different architectures into a complete prototype and then a complete product. So in our case, this is some of the earlier prototypes that we have. Okay, so we try to do different casing. So the size does matter because we try to compress, have a smaller design, but it's insufficient. So we have to increase the design. Then we have to increase the size, and we have to change the design to the final one that we settle with. Okay. So this is after going through a lot of discussion, iteration, and multiple rounds of prototype production. Okay. Now, so that is basically defining your product. So after you have defined your product, what you want to do, how it looks like, how it functions, then you have to start thinking about developing your product. Developing means bringing it to the next level, or bringing it to manufacturing. Okay, a lot of these steps I will show next is a repetition of what I just presented before, but is looking it from the angle of production. The motivation would be to understand how things will actually flow in an actual production. Okay. Just now we were just focusing on the product itself. Okay, we just wanted to make sure that product runs or product works. Now you want to bring that prototype into high volume manufacturing. Okay, so this is some of the steps involved. Again, this is not a universal rule, but some of the generally accepted flow that is involved in actually developing a product. Okay, so as we mentioned, everything starts with an idea. Okay, this is just a recap of the step before. So a great idea is a product of the intersection of a cool idea and a need that wants to be fulfilled. Okay, sometimes you have a cool idea, but the market doesn't need it. Or sometimes the market needs, but you cannot come up with the idea. Okay, so making cool ideas work well is even more challenging than coming up with a cool idea. Okay, not all successful products starts with cool idea. Okay, at least it's not original idea. It's in a lot of instances, successful projects actually comes from improving or performing incremental improvement on existing product. Okay, so it's not like, for example, in our case, we didn't invent the ECU. ECU exists, but we integrate wireless technology into the ECU so that we can unlock a lot of things. For example, wireless tuning or diagnostics on an ECU. So we didn't start by inventing an ECU. We start by performing or doing incremental improvement on existing product. Okay, so sometimes it might be previously cool idea, that someone else made, but it failed commercially, but you repackage it in a new way that might be successful. For example, the Apple Newton that we saw previously in the beginning, that was not a commercial success, right? But after Apple Newton, a company called Palm, they create a personal digital assistant called Palm Pilot. That has more commercial success than Apple Newton, right? So they didn't invent from scratch. So they didn't start everything from zero. It's just an existing technology, existing product. They create more. They do a more incremental improvement on existing product, and by doing that, they manage to get more commercial success. Okay, so you have idea, you have preliminary planning, and then you have to do reality check whether this idea is worthy of your time to do or not. Okay, so just have a reality check after you do your planning, a preliminary planning. If okay, then you just do a ballpark. You know, okay, what will your product do? What will it look like? Okay, how many people might want the product? How much they might want to pay for it? Okay, these are the questions you ask during your reality check. Okay, so the more questions you ask yourself, and the more you challenge yourself, the better angle you will get when actually doing the product development. So the next part will be the planning. Okay, so the involves project planning and then design, and then you have to do some risk assessment. Okay, so planning. So you have to plan your project, not product, not just product, but a project on its own, a project as a whole. You know, project of bringing the prototype to production. So you have to think like how much effort will be required to develop your product. How much will it cost to manufacture and ship? What are some good ways to market it, sell it? Okay, nowadays, you can go to like crowdfunding platforms like Kickstarter or Indiegogo to validate or first entry to market. And then you have to see, you have to ask yourself, have others tried this? Have they succeeded or failed? Why? Okay, ask yourself and then get the answer, and then ask why is your idea or execution different or better. So by asking this question during your planning step, you know, you can have a more meaningful planning at this point. And then product design. This is what we went through in detail previously, but just to recap. So product design is the science and art of creating specifications for users, for how users will interact with product. Okay, so it includes color, size, ergonomics, screens, workflows, and virtually everything needed to describe how your product presents itself to the world. Okay, so you have to understand what your product is. Okay, and then once you do your design, you have to perform a risk assessment. You know, it's basically a proof of concept, or proof of principle. Usually at this point, you won't have the final design, but a simple implementation that gives you confidence on knowing what the final design process will require, right? So for example, in our case, the ECU, it works on a bench, right? It works on a test bench, but is it ready to be tested on the real world, because it's a mission critical product, right? So those are the risk assessment that we have to do. So we start with a small scale implementation of the mainstream application of the product, but then you have to think about corner cases of how your product will be used, right? So then you can have, at this point, you can have another reality check whether you want to proceed or not, because at this point you just develop one prototype, right? Let's say you develop your prototype and then you discovered a potential fatal problem on your product during your risk assessment. Some corner cases would cause your product to not function, like whatever reason. So then you have to have a reality check whether that issue can be overcome or not. So if yes, then you can proceed with your plan to actually bring this to production. Okay, because from this point onwards, you will need to commit a lot of time and a lot of money to polish your idea and scaling up your production. Okay, so then it comes to the part of prototypes, prototyping, and testing, and purchasing. Okay, so prototypes, as we discussed, is usually created as part of a detailed product spec, as described earlier. Okay, so as you develop a product, you might want to change the design, whether it's electronic design, mechanical design, or even software design, because of engineering issues, technical issues, or it could be due to feedback from further market research. For example, while you do your prototype, you do a survey on a potential user of your product, and they say, oh, we don't like this product to be connected to Wi-Fi. We want it to connected to Bluetooth only. So maybe you would want to decide, okay, we should discard the Wi-Fi part. Okay, so for example, we don't mind to have a larger battery as long as it can last longer. So then you would, in your design, your electronic design, you would probably change your battery from a smaller one that you initially planned to use to a bigger one that comes from the information or feedback information you gain from your market survey. Things like that. So things can still change. Things are still fluid, still dynamic. Okay, at this point. So, so this is a breadboard. You see, it looks like you can plug in components in here, and you can actually get your product to function the way your final product should function. Okay. So after you do prototype, then usually you would do a lot of testing. Okay, so testing is how you find out about problems. Okay, as we mentioned just now in the principle of fundamental principle of product development, problems are always cheaper to fix if found early. Okay, so there are a lot of different tests. Generally, for example, these are 4 different tests that is usually found or usually done. So first is design verification. So this is making sure that the product's engineering design is correct. So you make sure your circuit works well. You don't the circuit should function the way it should be. Okay, so and then certification tests. Certification tests is maybe you would want to sell your product to Europe, so they have some standards you have to meet. So they have a list of things that you have to comply. Okay, so those are certification tests. Product validation. So product validation includes basically providing or giving prototypes of finished product to prospective users to see if the intended task that they should do does perform. So you to basically discover whether you can accomplish your product goals. Whether your users can actually gain benefit from your product. Okay. You can validate by sending out having like a group of testers, for example, or alpha users or beta testers. And then another part would probably be like a manufacturing test. So this involves catching any manufacturing imperfections during the process. Okay. So after you do various kind of testing on your product, you would go ahead and start thinking about purchasing. So purchasing means to buy components and parts from various different vendors from all over the world. Okay, some parts require custom order. For example, your plastic enclosure is done by injection molding process. So you would need to pay for the mold, plastic mold, okay, for your specific design. And then you would want to order like a volume. They usually have a minimum order quantity or MOQ. So for example, casing, you would need to pay for the mold, and then you need to pay for the minimum order of the plastic casing unit, 1,000, 10,000, depends on your vendor. Okay. Another product that is custom could be your printed circuit board. Okay, so you, based on your circuit design, you have a specific design of your board that needs to fit into your enclosure. Okay, so this is also another custom order. But there are a lot more things that can just use off-the-shelf solution. For example, just simple electronic components, right? You can just purchase from a distributor, or you can try to approach directly the manufacturer of the components. Connectors, yeah, things like that, you can just buy them off the shelf. Okay, batteries, for example, you don't create new batteries, you just buy off the shelf. Everybody uses this similar kind of battery. Okay, so once you have your parts ready, you would engage a factory. So usually there is something called contract manufacturers. So they would be able to perform the various part of your manufacturing. For example, you would want to assemble the components on your PCB, on your printed circuit board. Okay, so you would engage a custom contract manufacturer. So they don't only serve you, but they serve many other people who would need products to be manufactured also. So at the contract manufacturer, usually they will start with a step called NPI, New Product Introduction. So this NPI is a process of creating and proving processes to ensure that your final prototype will be reliably reproduced in the factory at high volumes at a reasonable cost, by machines and workers with moderate training and located far from your premise. So it's just a trial run, so to say. Or it's the first time your product is being produced at their factory. So everything needs to be in order. They need to set their machines, they need to train their workers, they need to schedule their production. So these are part of new product introduction. And they proceed with pilot build. Pilot build means the first run of your product. Okay, they closely examine the process, the steps, to look for inefficiencies, and they would want to produce. They would look for potential to produce non-conforming products. Product that is failed the test or beyond the mechanical tolerance, quality of soldering. So they pay close attention during this pilot build. And then they would also do certification and reliability testing during this step, okay, during this pilot build. So once you have done your pilot run or pilot build, you would have your product go on an ongoing production. So this is the final step before your product gets to the market, okay? So I will always think that products that you develop are your children, okay? It's like your children, because you remember, you start with an idea, okay, and then you run through many iterations of prototypes, and then before you finally have the product being manufactured on its own during volume production. So during volume production, you no longer monitor day to day the process, okay, by the design and development side. Only when the production side has any issues, they will contact you, and you need to troubleshoot the issues that arise. But generally, you let the manufacturer run your processes for you, okay? So you work with contract manufacturers, as I mentioned before. For example, even Apple, they engage with Foxconn, is a company as their contract manufacturer. So Foxconn, the one who build the iPhones and the iPods of the world, you know. You may do your final testing or packaging in-house if you are concerned about final quality, final reliability, and also if you want to keep your firmware inside your premise. You don't want to have people copying your product. Okay? You don't want to take the risk. So you can do the final testing, firmware loading in-house. Okay. After you have done your manufacturing steps, of course, the next step would be to sell it. So you have to market it, you have to sell it, you have to distribute it. So how to do that is a big topic on its own. Okay, but generally, until here, you can up to this point, you would have been able to manufacture your idea, your product from just an idea to an actual real product. Okay, so now I would want to just go through a bit what I would call like a deadly sins of product development. Okay, so what you shouldn't do, you shouldn't put off serious testing until the end of development. You would want to always try to perform tests as much as possible during various stage of your development. Okay, and then you you cannot assume you know everything about what the users want. For example, just now, like give example, users don't want Wi-Fi, they just want Bluetooth, or they just want Bluetooth, they don't want Wi-Fi, or they want a specific battery size. So these are the things that you can perform a small survey, for example, on your target market to determine what is best. But on the other hand, you cannot also assume that users know what they want. Okay, sometimes they don't know what they want. So it's up to you to provide with the solution that can help them. Okay, so these two are a bit tricky. It's a bit of an art. Okay, there's no specific answer for this. It comes from experience, or it comes from a bit of risk taking. You know, so you do some survey, and then you also have some. It comes from your gut, your instinct of what you want to present to the world. Okay, so a balance of these two, what users want and what you want to give users. Okay, and then you shouldn't have a lack of comprehensive requirement. So you need to list down your requirement as much as possible. That's the more requirement you list down, the better. The more comprehensive your requirement list is, the better your product will avoid, the better chances of your product to avoid surprises much later. Okay, you need to have a good project plan, okay, as we mentioned just now, and then not assigning responsibility. So you need to assign responsibility to the correct people. Okay, so that your project will run smoothly. Okay, you cannot have nobody is responsible for this task. You know, like at the end that will jeopardize the smooth flowing of your production. Not knowing when to quit polishing. So this is related to the prototype. Okay, so you would sometimes you just have to if you have done like your iteration up to 7, 8, 10, 9, 10 times, maybe you just have to take a risk that okay, this is the step where I think we should define our product and we should proceed with planning for development or planning for manufacturing. So because you know, like sometimes you do a lot of iteration, but they're always like, for example, you do your prototype up to Wi-Fi 4.0, okay, and then suddenly there's Wi-Fi 4.2 in the market. So do you want to cater for that? Do you want to build new prototype and spend more months doing that development for the new standard that's available in the market? Or you just go with whatever you have. So these are the kind of questions you need to ask, but you need to know when to stop polishing and start actually focusing on planning for manufacturing. And then you need to plan to fail. Planning to fail means, okay, what if something happened? What can you do? When like generally you need to plan to fail so that you won't get upset or surprised, and you need to know what to do when there's a failure happen along the path. Okay. And then developing technology rather than developing products. Sometimes you create things that is unnecessary. You think it's cool, you think it's nice, it's high tech, but there's no one wants to use it in the market. Okay, so this is also tricky, especially if you invent new technology, right? Sometimes you can hit the jackpot. You're lucky that the product that you build, and especially if you have patent on it, the market really likes it, so you can grow your business. But sometimes you build something, but it's high tech, but the market doesn't want it. So what do you do at that point? So should you give up, or so should you wait? These are the business decisions that you have to make. Okay. So the sooner you address all these deadly sins, I would say, the better of chance you have to avoid surprises. Okay. Okay, we are nearing the end. Okay, I just want to share some interesting patent. For example, a guy in the 1930s, I think, 1903. Okay, he patented glasses for chickens. Chicken goggles. So to him, you probably imagine that, soon there'll be a lot of chickens, and chicken would want to wear goggles. The chicken farmers would want to buy millions of these, but that did not happen, obviously. So if he had continued with his chicken goggles prototype and manufacture millions, like thousands of these, probably he wouldn't be able to sell. So this is something of a sometimes it's easy to fool ourselves by thinking of how cool or how useful our product will be, but that might not be the case in the actual market. People might not want that. So a lot of examples in the market, right? Like you can just Google products that fail, right? For example, Microsoft Zoom, Google Glasses, things like that. It's high tech consumer product, but it did not gain any traction in the market. So that happens. So now the question is, why should you start hardware startup? So you guys are still in school, right? So I don't know how much of this presentation sticks with you, but hopefully I just open your eyes to new information, right? But why should you one day consider doing a hardware startup? So the reasons that I can think of is, when you in the near future, 5G and above will become mainstream. So this is a game changer. Okay, communication will be it's a much different from what we have today. Okay, like data can be sent from all over the place at higher frequency, lower power. So Internet of Things will take off when 5G exists, right? So you can send a lot of data in very short time. So that is a reason. And then soon, dominance of artificial intelligence. So there'll be more AI that you can use to build new products. Okay, today maybe it doesn't exist yet. So the machine learning so is limited by what's available, what is accessible. But you don't need to create the AI. The AI might exist as a tool that you can use to create new product. Okay, and then voice assisted personal entertainment system. Okay, this will become more mainstream, and then what it is today. All your series will become more mainstream, all your Alexas. Okay, so what can you do? You know, how can you create product from this existing or this new tech? Smart homes will be more prevalent. Okay, today it might not be accessible or might not be available for most of markets in Malaysia, but in the future, more home will be converted to smart homes. Okay, so how can you fit in? Okay, what product can you put in their smart homes? Okay, and the auto industry, we're moving from combustion engine to EV in the future. Self-driving cars. So battery operated cars, motorcycles, personal mobility, it's like, so the auto industry is experiencing a revolution, so how can you take this opportunity, this advantage or this opportunity to create new product for the market? Okay, so these factors really present an opportunity to introduce exciting new consumer products that has not existed yet, for many new niche market. Because if you know, like consumer electronics, essential part of our daily routine. You cannot leave your home without your smartphone. You cannot leave your home without your smartwatch today. So yes, penetrated a lot of aspect of human life. So that's why a lot of companies are investing aggressively in innovation, in the hardware space. So, and then moreover, the rise in disposable incomes of people. The people are more willing to become new adopter of new technologies, So emerging middle class, they would want, like the generation today that grew up with smartphone, they would be more willing or more risk taking in trying out new product, new hardware in the future. Okay, once they have their own purchasing power, right? Like you guys, you guys are school goers now, but in the future, you guys might be the users of new technologies. So why not become a producer? Why just use? Why just consume? Okay, you have to think that you are able to create something that you can sell to the whole world. Okay, you can export it. Okay, so it's good for the country. So yeah, that's pretty much what my presentation is. I hope, I don't know how effective this will be, but I hope that maybe some of you would, my presentation has triggered, like a new perspective on you to think that, next time you look at your smartphone, you don't just look at the smartphone as a consumer. You look at your phone, you think about, this is a hardware technology. How did they make it? What are the steps that was involved in making it? So how can I, or how can we, or can you create your own hardware, that you can sell to the world? Okay, so why does it have to be Samsung? Why does it have to be Apple? Why can't Malaysia create our own brand? So it lies in your hands. You are schoolgoers, you are young, you are adaptive to new ideas. So you should read a lot. Okay, read a lot. Try to understand more of technology in general. Maybe you are not interested in hardware. Maybe you are interested in software, but you would appreciate what happens in hardware space when you develop your software. Yeah, so I'm excited about the future, and I'm excited about you guys. You guys are the hope of our country. So I hope that some of you who listen to this are motivated to actually learn more, go beyond your textbook and understand what's available out there, so that one day you guys can be the producer of hardware technology from this country. Thank you very much. Have a good day. Bye.
Perusahaan sosial itu adalah satu entiti yang tidak menolak soal perniagaan. Maka dalam tafsiran kita as social enterprise, you have to be a for-profit organisation. That means you have to have a going concern. You have to be a business, because we still believe that only through businesses are you incentivized enough to create a going operation. Tetapi kita nak pastikan bahawa ia bukan hanya soal perniagaan. Ia bukan hanya soal your EBITDA and also your shareholder value, but what is it that businesses are leaving behind for the community, and what are the businesses doing for the community in order to make it more sustainable, in order to address inequality, and in order to do good. Itulah kerana kenapa perusahaan sosial ini menjadi satu entiti yang penting untuk kita bangunkan. Dan saya melihat bahawa perusahaan sosial ini ada peranan yang penting bukan hanya dari segi inovasi bagi menyelesaikan masalah setempat, tetapi perusahaan sosial is a new model for businesses to contribute to the economy.
important that for policymakers to lift this or to extend this, it must be based on science and epidemiological facts.
Robotik, artificial intelligence, semua jenis teknologi yang diperlukan, kita sedang gembelit bagi membantu kerajaan.
From Tectonics, in support of National Science Week, we proudly present to you MESAT 2021, a collaborative effort of MOSTI, Technology Park Malaysia and Tectonics. Come and join us at MESAT 2021. Let's explore STEM and coding together with Biro Micro. Remember to sign up. I see you all soon.
ladang ini diwujudkan adalah disebabkan oleh satu tragedi yang menimpa kami, yaitu tragedi gempa bumi yang berlaku pada 2015. Assalamualaikum, hai, saya Azizul daripada Kundasang Sabah. Saya adalah graduan daripada Universiti Malaysia Sabah dan sekarang saya adalah founder kepada Kundasang Aqua Farm. Kundasang Aqua Farm menggunakan kaedah aquaponik sebagai kaedah penanaman sayur-sayuran dan juga penternakan ikan sekaligus dalam satu sistem yang sama. Yang mana ikan kita ternak dalam suatu tangki ternakan dan kita bagi makan ikan tersebut dengan pellet. Sisa daripada ikan tu kita tapis, kemudian daripada sisa tapisan tadi itu kita alirkan ke dalam media tanaman untuk dijadikan sebagai baja dan juga penyiraman kepada sayuran sekaligus. Di air yang akan kembali semula ke dalam ikan adalah air yang bersih. Nutrien yang berada di tanah sudah tidak mampu untuk menyuburkan sayuran kami lagi. Jadi perbezaan yang paling utama adalah dengan menggunakan teknik aquaponik ini, kita tidak akan kehabisan sumber nutrien. Saya berazam untuk meningkatkan pengeluaran sekitar 3 tan pada tahun hadapan dengan pembesaran 10 kali ganda daripada ladang sedia ada. Saya cukup berterima kasih dengan NIM kerana telah memberikan peluang kepada saya sebagai anak jati kampung Kundasang untuk mengusahakan ladang ini dengan memberikan dana bentuk grant, dan pada saya ini juga dapat dirasai secara sangat mendalam di kalangan para inovator akar umbi yang lain. Sekalung penghargaan dan apresiasi saya tujukan kepada Yayasan Inovasi Malaysia atas bimbingan dan telah menjadikan kami inovator akar umbi daripada sekadar mempunyai idea kepada menjadikannya menjadi realiti.
Perusahaan sosial itu adalah satu entiti yang tidak menolak soal perniagaan. Maka dalam tafsiran kita as social enterprise, you have to be a for-profit organisation. That means you have to have a going concern. You have to be a business, because we still believe that only through businesses are you incentivized enough to create a going operation. Tetapi kita nak pastikan bahawa ia bukan hanya soal perniagaan. Ia bukan hanya soal your EBITDA and also your shareholder value. But what is it that businesses are leaving behind for the community? And what are the businesses doing for the community in order to make it more sustainable, in order to address inequality, and in order to do good? Itulah kenapa perusahaan sosial ini menjadi satu entiti yang penting untuk kita bangunkan. Dan saya melihat bahawa perusahaan sosial ini ada peranan yang penting bukan hanya dari segi inovasi bagi menyelesaikan masalah setempat, tetapi perusahaan sosial is a new model for businesses to contribute to the economy.
important that for policymakers to lift this or to extend this, it must be based on science and epidemiological facts.
Robotik, artificial intelligence, semua jenis teknologi yang diperlukan kita sedang gembeleng bagi membantu kerajaan.